Billions of years ago, Mars was a world transformed by water. Rivers meandered across its red surface, carving deep valleys and filling ancient basins with lakes and seas. But over time, the planet's fragile atmosphere thinned, and its waters vanished, leaving behind the arid, rust-colored desert we see today. Yet, what if those oceans came back? What if Mars, once dry and desolate, were flooded anew with vast, rolling seas under a sky tinged with pink and blue? Imagine standing on the shores of the Martian northern lowlands, where an ancient ocean may have once stretched for thousands of kilometers. The horizon would shimmer with sunlight reflecting off gentle waves, the air crisp and cool, carrying the faint tang of salt. Clouds would drift lazily overhead, casting their shadows across distant islands and peninsulas. It's a scene both alien and familiar, a reminder that water, wherever it flows, brings the promise of life and transformation. For oceans to return to Mars, a cascade of extraordinary changes would have to unfold. First, the planet's atmosphere would need to thicken dramatically, trapping more heat from the distant sun. Today, Mars's atmosphere is only a whisper of what it once was: thin, cold, and unable to support liquid surface water. But if we could somehow restore it, perhaps by releasing greenhouse gases from Martian rocks and polar ices, we could warm the planet enough for ice to melt, rivers to flow, and rain to fall once more. With a revived atmosphere and rising temperatures, the frozen water locked beneath the surface and at the poles would begin to thaw. Ancient glaciers and permafrost would yield their secrets, releasing torrents of water into the lowlands. The largest of these lowlands, the northern plains, would fill first, forming a planet-spanning ocean larger than the Arctic Sea on Earth. Other regions, like the vast Hellas Basin and the deep valleys of Valles Marineris, would become inland seas and sprawling lakes. Such a transformation would utterly reshape Mars's climate. Oceans act as planetary thermostats, moderating temperatures and driving weather patterns. Winds would carry moisture from the seas inland, where it would fall as rain or snow, nurturing new rivers and lakes. The sky, once a lifeless beige, would come alive with shifting clouds and the occasional flash of lightning. Martian weather would be unpredictable and wild, a world in the throes of renewal. But with oceans come challenges. Mars' lower gravity, just 38% of Earth's, would give its waves a strange, slow-motion quality. Tides would be subtle, shaped more by the sun than by Mars' tiny moons, Phobos and Deimos. The Martian day, just over 24 hours, would add a familiar rhythm, but the thin atmosphere, even if thickened, would still offer little protection from cosmic rays and solar storms. The water itself, kept liquid by a greenhouse-warmed climate, would be cold, perhaps hovering just above freezing, depending on the precise composition of the atmosphere. Yet wherever water accumulates, life has a chance to emerge, or to return. On Earth, the earliest life forms arose in the ancient oceans, feeding off chemical energy and sunlight. Could the same happen on Mars? If any Martian microbes survived in underground aquifers, the return of surface water might offer them a new lease on life. Sunlight would penetrate the shallow seas, fueling photosynthesis and sparking an explosion of microbial diversity. Over centuries, entire ecosystems could evolve, simple at first, but growing ever more complex as time goes on. And what about the future of humanity on a blue Mars? Oceans would bring new opportunities and new hazards. Coastal cities could rise along the edges of the Great Northern Sea, their harbors bustling with ships and submarines. Martian fisheries might harvest exotic algae and crustaceans, while floating solar farms generate power from the relentless sun. The challenge of crossing these vast waters would inspire new technologies, sleek hydrofoils, submersibles, and even underwater habitats. But life on oceanic Mars would be anything but easy. The planet's gravity would affect our bodies over time, weakening bones and muscles. The atmosphere, though thicker, would still be less dense than Earth's, making every breath a challenge without assistance. The ever-present risk of cosmic radiation would demand protective shelters and innovative shielding. And the water itself, likely rich in dissolved minerals from Martian rocks, could be both a resource and a hazard, requiring careful management to avoid contamination and preserve its purity. The return of Martian oceans would also rewrite the planet's geology. Water is a powerful force of erosion, capable of carving new canyons, building deltas, and burying old landscapes beneath layers of sediment. Over thousands of years, the face of Mars would change, as rivers cut fresh paths and waves sculpt new coastlines. Volcanoes might awaken, their heat driving hydrothermal vents beneath the sea, creating oases of warmth and energy in the cold depths. From orbit, a blue Mars would be a breathtaking sight. The northern hemisphere would gleam with the deep blues and greens of its ocean, while the southern highlands, dotted with lakes and rivers, would wear a patchwork of ochre and azure. Polar ice caps would still cling to the poles, but smaller and more dynamic, their meltwaters feeding the planet's new hydrological cycle. The boundary between land and sea would be in constant flux, shaped by climate, geology, and the march of time. What would this new Mars mean for science and exploration? The return of oceans would open vast new frontiers for discovery. Marine biologists, geologists, and climatologists would flock to study the planet's rebirth, seeking clues to the origins of life and the forces that shape worlds. Robotic submarines could probe the depths of Martian seas, mapping their floors and searching for signs of life. Satellites would track weather systems and ocean currents, building a new understanding of Martian meteorology. The search for life would take on a new urgency. Any living organisms found in the oceans of Mars would be the most profound discovery in human history, proof that life is not unique to Earth. Even if the seas were sterile, their chemistry would offer vital clues about the planet's potential to support biology. The study of Martian oceans could teach us about the resilience of life, the fragility of climates, and the possibilities for terraforming other worlds. Yet, the return of oceans to Mars is not just a scientific fantasy. It's a vision with profound implications for humanity's future. As we look to the stars and dream of settling new worlds, the lessons of a blue Mars remind us of the power and responsibility we hold. To bring water back to Mars would be an act of planetary engineering on a scale never before attempted. It would demand patience, ingenuity, and respect for the delicate balance of planetary systems. The story of Mars is, in many ways, a mirror of our own planet's history. Earth, too, has seen its climates shift, its seas rise and fall, its landscapes transformed by the forces of water and time. By studying what might happen if oceans returned to Mars, we gain perspective on our own world, its beauty, its vulnerability, and its capacity for renewal. So, what if Mars had oceans once more? It would be a world reborn, a place of wonder and possibility. The red planet would become a blue world, its landscape softened by rain and sculpted by waves, its skies alive with clouds and storms. Life in all its forms would have a new canvas on which to paint its story. And humanity, standing on the shores of a Martian sea, would gaze across the water and dream of new horizons, of worlds yet to be discovered and futures yet to be written. The journey to a blue Mars would not be easy. It would take centuries of effort, the harnessing of technologies we have only begun to imagine. But the rewards, a living, breathing, oceanic world, would be beyond measure. It would be a testament to our curiosity, our creativity, and our enduring hope for the future. As we imagine waves crashing on Martian beaches, rivers flowing through ancient valleys, and clouds dancing across a pink and blue sky, we are reminded of the power of water to transform worlds. Oceans are not just bodies of water. They are engines of change, cradles of life, and harbingers of possibility. If Mars had oceans once more, it would be a place of endless adventure, a world where the past meets the future, and where the dream of life beyond Earth becomes at last a reality.